Dear ladies and gentlemen, I send my greetings to you, participants of the International Conference on Communication and Information Technologies and Natural Science Education at Siauliai University, Lithuania, couple works in Belarus. Мои щирые привітання коллегам з Білорусі, доктору Тодору Лахвичу, доктору Олегі Матерівській і доктору Маргариті Писоник. I come to you from the University of Oregon, which is in the city of Eugene, the Pacific Northwest of the United States. Among other units, there is College of Arts and Sciences at the University of Oregon and Chemistry Department, where I teach general chemistry.
I apologize for the low quality of this live video recording and change now for studio production. Actually, I am teaching chemistry now in the third language in my life, as before I have taught organics for 15 years at Vitebsk State University in Belarusian and Russian. Here I am with my students at Vitebsk State University. The graduates of UFO College of Arts and Sciences go primarily into science and industry, and there is also a College of Education at UFO, whose alumni are mostly teachers, and its Center for Advanced Technology in Education, CATE, where I am affiliated as a research associate. The center implements projects on grants from US Department of Education, National Endowment for Humanities, National Science Foundation. There are 4 main strands of research and respectively 4 divisions at CATE. Center for Electronic Studying, Center for Global Teaching, having collaborative connections with India, Mexico, Russia, Oregon Writing Project as a part of National Writing Project, and Center for Learning in Virtual Environments. It focuses on 3D immersive environments like Second Life. Its first initiative was Salamander project, with the goal of finding and annotating all resources in Second Life that could be potentially useful for education. Annually, CLIVE organizes immersive education days at University of Oregon. My colleagues, faculty at colleges at universities here use Moodle and grade other academic platforms. The UFO faculty officially use Blackboard, and so do I. Although teaching my course, I try to integrate all useful internet applications and also use a Google Blogger. I upload my presentations to SlideShare and embed the code here. I encourage students to use Wikipedia, to use some chemistry YouTube videos. Normally I have some international students in the roster, and this translating gadget from Google is helpful for them. The translations sometimes are funny, though. And here, along with links to websites on my colleagues, I have a link to my office in Second Life. Students and colleagues can meet me there fairly often. The map shows where. I apologize for being so annoying. Probably everyone participating in this conference knows it perfectly, so I just want to remind that Second Life is a 3D virtual environment where you can shop, explore, love, play, and what is critical for us, learn. Just like when you wish to use Skype, you have to register on Second Life website. You can make up only your first name and have to choose the last name from the list. And then you need to download and install the Second Life viewer. Once you're done, log into Second Life. Normally I have some international students in the roster, and this translating gadget from Google is helpful for them. The translations sometimes are funny, though. And here, along with links to websites on my colleagues, I have a link to my office in Second Life. Students and colleagues can meet me there fairly often. The map shows where. I apologize for being so annoying. Probably everyone participating in this conference knows it perfectly, so I just want to remind that Second Life is a 3D virtual environment where you can shop, explore, love, play, and what is critical for us, learn. Just like when you wish to use Skype, you have to register on Second Life website. You can make up only your first name and have to choose the last name from the list. And then you need to download and install the Second Life viewer. Once you're done, log into Second Life. And now I say you my hello from virtual Belarus. Many real countries are now in Second Life. Some opened embassies there. The first were Maldives, then Sweden came, then Estonia, then Colombia, Serbia, Macedonia, Philippines, Albania, Malta is planning. From here now let me consider Second Life from the perspective of its use for chemistry researchers, chemistry teachers and chemistry students. Don't be surprised, I feel comfortable standing there, the water is pretty warm. The first use is that Second Life constitutes a social network, just like Facebook or LinkedIn or Odnoklassniki or MySpace. When we click on search button and enter chemistry, we can find people who chose this word as their name for some reason, probably serious academic reason. We can search for group emphasizing chemistry. Please note American Society and Royal Chemical Society in this list. We can also try to locate chemical places. There are Island of American Chemical Society and Island of Aldrich Chemical Company here. So it is now time to explain where I am. It is the Island of American Chemical Society. This is how I make chemical friends in Second Life. I scan their profiles. Plenty of nice information here. What groups the person belongs to, their websites or blogs, their skills and language proficiency, their favorite places to go in Second Life, some real-life information. Or I can look up the list of a group and find interesting people there, like in these groups: American Chemical Society, Royal Chemical Society, Higher Education in Second Life. Another good way to find chemical friends, well, let's say colleague educators, is to participate in virtual conferences in Second Life. I have a suggestion that Siauliai University buy an island, build a good facility to hang out at, and organize a series of virtual events in Second Life. At such events you can meet very devoted personalities, sometimes obviously tired of belonging to species of Homo sapiens. Oh, by the way, it's opening of the National Chemistry Week in Second Life, 19th of October. Chemistry without history of chemistry, without poetry of chemistry, without chemical folklore, without, I would even say, chemical gossips, is dry and boring. The second use of Second Life for chemistry-related people is a vehicle of humanitarialization. To show how it may look like, let us fly now from ACS Island to Aldrich Island. We are flying now over highway. By no traffic. Extensive infrastructure, landscapes that Aldrich can afford, it's a rich company. To the Art of Science exhibit, with statue outside, inspiring to study science and chemistry at the Center of Science. I think we should harness pseudochemistry, quasi-chemistry, parachemistry, even alchemy to stimulate student interest to chemistry. All vehicles are good. Oh, here we go. Chemistry Hall of Fame. Certainly the number of chemists is great, so we can make more statues or hand portraits. It's easier. We can click on any guy around here and learn what he is famous for. Who's that? On click, the statue gives us a note card to read. So it's Abu Musa ibn Hayyan, also known as Geber, inventor of over 20 types of basic chemical equipment. Why not building national chemical galleries? Polish chemists, Ukrainian chemists, French chemists. So this one is a German chemist, Erwin Schrödinger, author of an awesome equation. Some popular internet services like YouTube can be streamed into Second Life, like this chemical cinema where everyone can pick an element and watch a video about. This cinema functions as a social network. We can invite our kids to watch movies in world. We are community, we are united on a basis of chemistry. And it is also a vehicle of humanitarialization because videos can feature people in association with chemistry. Let us now address Second Life as a learning environment for chemists too, not only for students. These are poster presentations by professional researchers in Second Life. They are clickable, so we can instantly read about what our colleagues are doing. As you may have understood, we are back to the island of American Chemical Society. Let us check what they have inside. It's a decent building, modern, even modern. Freebies. It means we can grab this stuff for free. Molecule Razor. We can raise or retrieve, put a molecule in Second Life and it is going to be 3D. T-shirts, lab coat and safety goggles, probably not so useful as in real life, but who knows. Periodic table is gorgeous. Assortment of molecules, always welcome. And let me buy this nice chemical carpet for $0 Linden. Greatest. Once we are in Second Life and concerned about chemical education, we should collect everything. Relevant, irrelevant, we can sort it later. Let us check out this interactive chemical museum. What we see entering and all around are molecular models. Rotating, seldom static, of simple compounds and complex ones, helping students to realize what it's like to be a molecule. A good visualization instrument to compensate lack of spatial imagination. And the learner is always in there, by the molecule, with the molecule. It's an absolute presence. Macro world and micro world merge in world. Chemistry is abundant in concepts that are tough to understand, not solely because they often involve a lot of mathematics, but because of incomparability of macro world and micro world in principle. We apply common sense to imagine micro-world, and at the same time we say that our imagination is limited and the macro experience is not applicable. An example is Heisenberg's principle of uncertainty, chemical bond theory, VSEPR and MO, and this set of atomic orbitals is to facilitate student understanding. One can take it to the inventory and then elsewhere res, compare, manipulate. The point is that we can make particles in Second Life behave according to our theories. Another issue is how consistent our theories are. Anyway, I believe that Second Life is a unique, immersive environment where people and molecules can live together, where people can better understand molecules through other people, and eventually better understand each other through molecules. Using this device in Second Life, one can manually run a chemical reaction. We see a big molecule, and to initiate a chemical change it is enough to type in a word, next, and this change occurs immediately. To run the reaction in reverse direction, we type in back, and the products convert to the reactants. On this device, one can observe and run, on molecular level, the reaction of polycondensation, synthesis of nylon 6,6. Hexamethylene diamine molecules are coming from the left, hexane dioic acid is joining from the right, and the polymer chain is growing forever, producing molecules of water as byproduct. This 3D diagram is to teach the selection rules in atomic levels. Allowed transitions are green, forbidden are red, whereas yellow stands for the current state. As we click on a specific energy sublevel, we see the sublevels for which the transitions are allowed or forbidden. Let us try out the periodic table available greatest at ACS Island. Drag it from our inventory and res someplace. One more version of the periodic system. Let us click on element potassium column. We have all the basic information about some history of discovery, its appearance, behavior and uses, and it works for any element. Now I'm reporting to you from nearby a magnesium atom, risking to be hit by an aggressive electron. Actually, I'm kidding. In Second Life you can create things as phantom or physical, so these electrons are phantoms. I'm walking through the electron shell and manage to sit down on the nucleus. Amazing! Well, it's Bohr's obsolete model of atomic structure, yes, but it makes me feel involved, and I built this system in Second Life in 15 minutes. Here is what we can do with the assortment of molecules we saw at ACS Island. We can raise any of these molecules: ampicillin, benzene, caffeine, cholesterol, aspirin, sucrose, nicotine. And if we want them bigger, okay, we can magnify them. Now let us consider Second Life as a producing studio. For example, molecule we have just seen can be presented as an anaglyphic picture, and if you have special 3D glasses, one glass is red and another is green, you can enjoy this molecule with 3D. And it is Second Life that I took the two pictures of these molecules in with a shift that equals approximately the distance between human pupils. And it is Second Life that I can experiment with day, night, evening or morning, finding the best lighting to give a spatial taste of molecules. Another way to achieve the 3D effect is to produce stereo pictures of molecules. This way is technologically simpler and ensures natural colors, but has a limitation: pictures cannot be big. Actually, distance between their centers should be about the distance between our pupils. Again, to produce stereo pictures I used Second Life. We can limit ourselves to chemical topics, or we can produce whatever of this kind, educational or just enriching. At some of my lectures I provide students with 3D glasses, turn off the light in the auditorium and project anaglyphic molecules and atomic orbitals. Students are happy. So to recapitalize, Second Life for the purposes of teaching chemistry can be considered as a social network, as a vehicle of humanitarialization, as a learning environment and